data structure, that is applications of stack. Okay, so first application is recursion, then the validity of parenthesis, and third one is expression conversion. So based on this expression conversion, as far as your practical is concerned, we have practical number 3 for the same application expression conversion. Okay, so similar to stack, we have the another data structure called as queue, where in queue similar kind of things we will cover. First of all, we'll go through the basics of queue, then its representation, then we'll go in detail of what are the types of queue. In that we will discuss the first thing, linear queue, then the second thing is circular queue, then we'll go for double ended queue, and at last we'll go for priority queue. And there are two applications we need to consider for queue. First one is job scheduling, and other one is Josephus problem. Okay, and as far as this unit number 3 is concerned, we have one case study, that is evaluation of postfix expression using stack, and same thing is there for your practical. Okay, so this much syllabus is there for unit number 3. So simply you can observe that in this particular syllabus, the first portion which is for stack, the other portion is for queue, and the case study is mentioned which is using the basics of stack. So this way unit number 3 is there. Okay, so is that any problem in the points which are available in front of you, the syllabus points of unit number 3?
No, sir.
Okay, so the overview of this unit is clear? Please reply. Rohit? See.
Yes, sir.
Okay, so the two things which are in front of you, one is stack, its fundamentals, then its representation. Now one thing is added in the discussion, that is we have to consider implementation of both stack and queue with the help of two ways. The first way is using array, how can we represent the stack, and using linked list, how can we represent stack. Okay, similarly for queue we are using this two-way representation. We are using array as well as linked list representation for queue. Okay, so stack and queue representation with the help of array as well as with the help of linked list. These two things we have to discuss under the head of queue and stack representation. So this way the entire syllabus is there. See, first of all we'll have the fundamentals, then the representation of that particular data type, then we are having what are the applications of those data types. Okay, so this way things are there in front of you. Okay, so please unmute. Who is please unmute? Roll number 64, please unmute. Okay, thank you. So like this we will go in detail of this unit number 3, stack and queue. Now to understand stack, we must have basic idea about what is called as array. Okay, and most of you are aware about what is array. So basically array is a collection of items. Okay, so array is a collection of variables or some data in the data which is of similar kind. In other words, this similar kind is called as same data type. Okay, so the data which is of similar kind can be grouped into one container, and that container can be called as array. Okay, so to go in detail of what is the stack and queue, we must have some basics of what is called as array. Okay, for that we'll consider some introductory part of array which will be helpful for understanding the concepts of stack and queue in detail afterwards. Okay, that's why I'm considering this particular part first. So let us have some background. With this background we can able to get details of stack and queue. Okay, so for that, what is array? Array is a collection of variables which is of similar kind. In other words, this similar kind can be considered as a similar data type element can be grouped together with the help of a collection, and that collection is called as array. Okay, now one important thing that we need to understand for this array is we cannot group different types of elements in an array. Okay, so it cannot be a combination of integer or character or float. So it must be of similar kind. So wherever we are making a collection, that collection must be of similar kind. That's why the statement which is in front of you is array is collection of variables which is of similar data type. This thing you need to understand first, then we'll go in detail of all the remaining part. Okay, and for that the subroutine statement is there. We cannot group different types elements in a array. Okay, for example, we cannot have a combination of integer, character or character float. So n number of combinations are there. We cannot have these combinations with the help of array. Okay, in other words, array can be called as homogeneous data type. Okay, so homogeneous means similar kind of data elements can be grouped together with the help of a collection. That's why the collective name which is there for the collection is homogeneous data type. In other words, this homogeneous data type can be considered as a array. Such type of questions will be there in your online examination. Array can be called as. Okay, so this way the alternative question, the MCQ questions can be possible. Okay. Now, one example, simple example is in front of you where we can have the array elements, integer array of 5 elements. So see, the elements are 10, 20, 30, 40 and 50. And one more important thing, we are arranging the elements of array one after another. Check, first 10 is written, then 20 is written, then 30 is written, then 40 is written, then 50 is written. And all these integers are kept on some location, and for that location see some numbers are in below written 1000, 1004, 1008, 1012, 1016. These are the memory locations. On the memory location these elements are kept in a some location is there, and with that location the elements are kept. Okay, and the location is represented by means of some number. Okay, and one more thing that can you observe here, the representation of these numbers with the help of array. So see how the representation is there. Array of 0, array of 1, array of 2, array of 3, array of 4. Okay, so what is this array of 1? What is this array of 0, array of 2, array of 3, array of 4? So basically these are the indexing associated with the array. Okay, so basically what indexing is representing. So check here, using index value we can directly access the desired element in the array. And one important thing that we need to consider is an array indexing starts with 0, not with 1. That's why in this particular representation you can easily observe that array of 0 is mentioned instead of array of 1 for element number 10. Is that clear? Yes? Yes, anyone can tell me what is array indexing and how this is there? Roll number 12, please reply.
Yes, sir.
Okay.
Sir, first element has a 0 index, second element has 1 index.
Correct. So in all, if you have 5 elements, the index at max index which is there for this case is how much it is? 4. Correct. Okay, so the important thing that we need to consider is array index starts with 0, not with 1. And if you want to access the first element, we have to specify what? Index 0. If I want to access element number 20, in that case, what index I have to give? 1. Okay, so likewise, we can go in detail of all this. Okay, to access the fifth element, we can use index 4, that is array of 4. Okay, so likewise, we can have, suppose a number is there. Suppose this the elements, 5 elements are there. In that case, your index must return 4. Okay, so in general, if I have, we can manipulate the nth element by using index n minus 1. This is the common policy which is adopted for any kind of representation of array. Okay, in general, size of array, if suppose n, then the index starts with 0 and it ends with n minus 1. This must be very much clear to you. because here onwards this requires. Okay, so I think everyone is clear about this indexing. If you have any doubt, you can ask me. We'll go slowly. Okay. Do you have any doubt in this? It's very simple representation. Roll number
No, sir.
11. You have any doubt? Roll number 11.
No, sir.
Okay. Okay. Next. Now, as we are now in the process of deciding what is unit number 3, and we have to give detail of unit number 3 in detail. So basically, we have to discuss what is stack. Okay. So stack is one data structure. Okay. Data structure means the way in which information is kept and can be retrieved for getting the variable, getting to the asking it, right? So in general, by definition, what is stack? Stack is a linear data structure which follows the principle. That principle is called as last in first out principle. Okay, so just keep in mind what is last in first out principle. We'll have a simple example, and with that example we can give details of this. Okay, so just keep in mind what is the working principle of this array. Array is having a principle of working named as last in first out principle. Okay, so what is this? We'll have a simple example. Okay, we are using this example in our day-to-day life. Okay, so check what is that example. Okay, so see, today itself, if I want to have information about stack, what I will do, I will just Google it on browser. What I will write, I will write what is stack, and we'll get n number of pages. Okay, now the pages are there, one after another pages will be there, right? So if I am interested for the first page, I will click on it. Okay, if I am not interested in the first page, what I will do, I will just click on the back button and we'll go for the initial page, which is there for the name, what for the purpose, what is the stack. Okay, so that way, if I have the, suppose if I written a first page www.google.com and I have written some sample page for getting what is called a stack, in that case I will get n number of pages, and if I don't want second page, I will go to the first page, again I will go for the second site, I will go for the third site. So everywhere what I will do, I will go back. Okay, every time I will insert the element and I will extract that particular element from the first end. Okay, so this way, if I have the list of sites one after another and I'm not interested in the second, third site, in that case, what I will do, I will remove that site by getting back to the original page and will get into action again and again. So this way, the browser which is using the back button is nothing but the use of first in last in first out principle. Okay, so how it works, check. If you have a stack of coins, okay, which is kept on one after another, and if I want to get the coin, obviously what I will do, I will use the top element and I will get that particular coin back. Okay, so this way the normal procedure is happening. Okay, so everywhere what is the thing, we have keeping the information one after another, and if I want to get the information directly, I cannot get the last coin, obviously I will go for the first coin. Okay, so likewise, if I keep a group of books, definitely I will, if I want to find the particular book, in that case what I will do, I will use the first element, first book, and then of course I will go to the second, third, like this, the first book. Okay, now similarly in a computer stack, if I insert the information, I will insert information by compartment 1, 2, 3. And if I want to get the information, obviously I will go for the first compartment, right? So this is the natural procedure, and everywhere this procedure is followed. Okay. So are you agree on this particular thing? Please reply. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now in detail, what is now stack? Okay. So stack is a data structure that store the element in such a way that the last piece of data is stored is first retrieved. This statement is very important. Okay. And this is a definition. By definition, what is stack? If you asked what is stack by definition, so you have to reply this particular definition. Stack is a data structure that stores data in a way that last piece of data stored is retrieved first. Okay. And the principle of working of this particular analogy is called as last in first out principle. And one important thing which is added in this particular definition, only access to the stack is on the top element. Okay, only access to the stack is with the help of top element. Just now you have observed one diagram. In this you can see wherever we are dealing with the stack, the collection, we are dealing with the top element. That's why only access to the stack is with the help of top element. Okay, so you can have n number of applications, n number of examples, real time example, wherever you have a collection, and wherever the collection is getting back the information with the last entered element. In that case, we are using a stack. This is the in general statement which is there for the stack. Okay, now along with this, the few more things which are added in the discussion. The basic two operations which are available with the stack. The first operation is called as push operation, and the second operation is called as pop operation. These are the basic two operations which are there for stack. Okay. So what is push? The operation is to place a new atom at the top of the stack. Now see, in between we are not inserting the element. Okay, every time we are inserting element on the top. Okay, and the procedure by means of which we are responsible for storing that element in the stack, this particular procedure is called as push. Okay, the operation to place a new atom at the top of the stack is called as push operation, and the second one is pop operation, the operation to remove the next element from the top of the stack. Okay, so everywhere, see, either you want to insert the element or we have to extract the element, we are using the top. Okay, both way, either for insertion as well as for extraction, removal, we are using the top. Okay, and with the help of insertion, we are calling it as a push operation, and for extraction or removal of the particular element, we are calling it as a pop operation. So these are the basic two operations which are associated with stack. Okay, so the first operation is push, inserting element in the stack on the top, and second one is removing a particular element from the stack with the help of top, is called as pop. Okay, with the diagram you can have this analogy. Suppose we have two elements in a stack, and currently the stack top is holding the first element, and if you want to insert one data, see, one data is coming to you and we have to insert that data. In that case, which operation we are using? Push operation we are using. And with that push operation, if the capacity of stack is there, in that case we can insert the data. If it is not, in that case the stack will reply that there is no place for insertion. Okay, now a new top of this stack becomes the newly added element. Yes or no? This diagram is clear?
Yes, sir.
Okay. So simply, if I want to add some data, the data will be inserted at the top, and now top becomes the new data inserted element. Okay. Next, pop. Now see, right now how many elements in our stack? We have 3 elements in a stack, and top is holding the first element. And which operation we have to apply now? Pop pop operation we have to apply. That means we have to extract this particular inserted data. So that data will be extracted with the help of pop, and a new stack is formed, which is considering now holding how many elements? 2 elements, and the current top is specifying the second element. By indexing, it is the first element, 0, 1. Okay, so first of all, how many elements are there in the top? In the stack, 3 elements. Now, with the pop operation, how many elements now? 2 elements are there in the stack. Okay, so what is role of pop? It is responsible for removing the element. And which element is removed? First element is removed. Similarly, what is the role of push? It is responsible for inserting the element, where it insert the element on the top of the stack. Okay, so these are the two basic examples representation where you can analyze the exact role of what is called as push and pop. Okay, and what about the top? Top is the first element. Yes, top is the first element of stack, and it can be either used for push as well as it is used for pop. Okay, so these 3 diagrams are clear. First diagram is inserting the element. Second diagram is extracting the element, and third diagram is representing what is the stack top. Is that clear?
Yes, sir.
Is that clear?
Yes, sir.
Okay. Up to this, anybody is having any kind of difficulty can ask me. Yes? Do you have any doubt? If no, then we'll go for the next point. Now, implementing a stack. Okay, there are 3 different ways by means of which we can able to implement the stack. Okay, and as far as your syllabus is concerned, there are 2 implementations given, one with array, other with linked list, and one more is there, that is vector. But for your syllabus, there is no vector mentioned. Okay, so see the syllabus. Let's have a look on the syllabus. See, stack representation using array and linked list. Okay, and operations. Just now we have seen the operations, push, pop. Okay, now stack representation using array and linked list is the point which is mentioned in the syllabus. Okay, and the representation with the help of array and with the help of linked list. Today we'll have discussion on what is the stack representation using array. Okay, somebody just mute yourself, students. Please mute yourself. Okay, so we'll have implementation of the representation of this stack using array. Okay, and then of course we'll go for linked list. Okay. So see, how can we represent array with the help of, how can we represent stack with the help of array? Okay, so there are 3 methods basically for representation of stack: array, vector, and linked list. For your syllabus, there are 2 methods: array and linked list. Okay, each method is having its own advantages and disadvantages. First of all, we'll go through the method. Then, of course, we'll go for its the advantages and its disadvantages. Okay, so here this slide we will keep at the end. Okay, what is this? Is the advantages of using array, disadvantages, and how the basic implementation. This particular slide we will keep at the end. Okay, just sake of understanding, keep in mind that by means of using array we can give the best performance, and disadvantages, it is concerned with fixed size. What is this? We'll discuss after discussion of implementation of stack using array. Okay, so I will keep this slide aside. After end of the implementation using array, we will have a discussion on this particular slide. Okay, next, see the requirements for getting details against this stack with the help of array. So first and foremost thing is we have to represent array. And what is the representation for array? Array can be represented with the help of its data type. For example, integer array of size so and so. Okay, And to point the index of the last inserted data, what we are using? We are using a top. Okay, so it is integer top. Then the first thing, which is first function which is associated with the stack is stack is full. If I want to insert something, and if suppose already stack is having its elements, in that case we cannot able to insert the element. In that case, we must have idea about whether the particular stack is full or not. For that, we are using one function, is integer is stack is full, stack full. What is the role of this function? This function will return true if stack is full, otherwise it will return 0. Okay, and if it replies 1, that means stack is already full, we cannot able to insert the data. Okay, there should be some space, there should be some vacancy for inserting the element. And how to check this? Just check whether the particular stack is full or not. If it is not, in that case we can insert the element, otherwise we cannot insert the element. Okay, this is the first method that is we have to consider for basic understanding of stack using array. Then the second one is push function will insert the data on the top of the stack. And which method is used? Void push integer. Okay, then the third thing is stack is empty. If suppose I want to extract some information from the stack, but stack is already empty, in that case I cannot remove element because already the stack is empty, there is no element in the stack. In that particular case, I cannot extract the information, I cannot remove the information from the stack. Okay, and this particular thing can be checked with the help of this function, is stack empty. If it is returning true, that means stack is empty, we cannot extract the information, otherwise it will return false. If it is false, in that case we can able to extract the information, extract the element. Okay, and which method we are using for the extraction? Pop method. It retrieves the last inserted data. What is the syntax for writing this? Void pop. Okay, so these are the four basic things we have to discuss. Basic four methods which are there for implementing a stack using array as well as using linked list. In both cases, these four things we need to understand first. Okay, is stack is full, is stack is empty, then push the data and pop the data. Okay, so these four basic methods are suitable for implementation of stack using array as well as using linked list. Up to this, it is clear? Yes or no? Hello?
Yes, sir.
Okay. Roll number 71, please reply. Roll number 71.
Yes, sir.
Everything is clear?
Yes, sir.
Okay. Good. So these are the four basic things. Now, the actual implementation, we'll have an example. With that example, you can come to know how this particular functioning of the stack is there. Okay, for that, let's have an example. Okay, and one important thing that you must consider, always top is giving. Now see, the indexing of array starts with 0, ends with n-1. Okay, in first slide itself we have seen this. Check here, in this particular thing we have discussed that array indexing starts with 0, not with 1. Okay, and the top is always having the position which is given with the help of this thing. Top is always equal to -1. Okay, and what it indicates? It indicates the empty stack. A stack is empty if top is -1. Okay, now let assume that array, we have to create one array, and using stack we have to create an array of size 5. Okay, so what is the size given? Size equal to 5. Currently, what is the stack? Stack is initially empty. There is no data in the stack. That's why the top is given as -1. Top is equal to -1. What it indicates? It indicates stack has no elements or it is a empty stack. And how many elements we have to insert in this particular thing? In this particular stack, we have to insert 5 elements. That's why we have given a size 5. Okay. Now, if I given size 5, how indexing can be possible with the stack? With the help of array 0, array 1, array 2, array 3, array 4. Okay, so likewise, as we have size 5, indexing must ends with 4 and starts with 0. Okay, and the representation can be written as array of 0, array of 1, array of 2, array of 3, and array of 4. What indicates? What it indicates? It indicates that there are 5 elements in the stack. Okay, starting with 0th index, it will ends with the 4th index. Okay, 0, 1, 2, 3, and 4. 5 elements we have to insert in the stack. Okay, so one by one we'll insert the element. Now check. To push the data into stack, check the stack is full or not. Initially, stack is not full because it is empty. The reason is top is specified as -1. Indication of top is equal to -1 means stack is empty. There is no element. Okay, and for that, is stack full? Is the what is the return for this particular method? Yes, anyone can tell me what it indicates? What will, for this particular example, what will this is stack full will reply? What will be the output for this first function?
False, 0.
0.
Correct. Correct. So this is false. That's why we can able to insert the element. Okay. Now, what I will do? I want to insert element 10. Push 10. What I will do now? I will what this particular data structure will do now? It will insert the element whose value is 10 with the help of a function, with the help of the method push 10. Okay, so what see here, push 10 is the method. For that, what we have to do? We have to increment the top by 1 element. Okay, so top is equal to top plus 1. What it indicates? Initially, what is the value of top? It is -1. Now, first element we have to insert. Okay, so increment the top variable by 1 for insertion of the data if stack is empty. So -1 plus 1, 0. So 0, what 0 indicates? This 0 indicates the index. Okay, now index is 0, and on that index insert the data. What is the data? 10. Okay, so what I'm doing? I am having a size of array 5, and currently what is my top? It is -1. What I want to do? I want to insert element 10. For that, what we have to do? We have to increment the top. Okay, and how to increment the top? Just by adding top is equal to top plus 1. Current value of top is -1. Now, what value we have to insert one element? That's why I'm adding 1 there. -1 plus 1, 0. What this 0 indicates? This 0 indicates the first indexed element of the array will be inserted by the value 10. Okay, so now top is equal to 0, pointing to the last inserted element index, which is given by means of the value 10. Roll number 5.
Yes, sir. Clear, sir.
Okay, okay. Now, what I will do? What is my size of the array? 5. How many elements I can insert in this array now? I can insert how many elements ahead of this? I can insert 4 elements ahead of this. Yes or no? Because there is empty space. Okay, so one by one we will increment the count of index by adding we are applying the same procedure. Top is equal to top plus 1. Okay, if I want the next element, push 13, what I will do? Right now, what is the top? It is 0. And always we are incrementing it by 1. By, of course, by checking what? This condition. Is stack is full. If it is not, in that case, we can able to insert the element. Okay, so what is the second element that we have to insert in the stack? 13. Okay, so 13. Now, current top of this particular stack is 0. I want to insert element. That's why which method I am applying here, push 13 with the supportive statement top is equal to top plus 1. Current top is 0 and it will be added by 1. So its index will be incremented and now index becomes 1. On that particular index, put this value 13. Okay. Likewise, we can go for third element, fourth element and fifth element. Yes or no? So check. The third element is 5. Currently, what is the top? It is 1. Now, 1 is added with 1 becomes 2. And that 2 will hold the second index, array of 2. And on that index, we will keeping this information, this particular value 5. Okay. Likewise, we can go for the third next element. I want to push 26. For that, current top is 2, will be added with 1. It becomes 3 and index position will be now becomes 3 and on that particular 3 I will insert the element 26. Okay, now next push 100. Current top is 3, will be added with 1 becomes 4. Then it will be given with the fourth indexed element and will be shifted, will be responsible for holding that information, that is 100. Up to this it is clear? Yes or no?
Yes, sir.
Okay, next. Now, push 78. Possible? Is that possible?
No.
Reason is?
Stack is full.
Correct. Stack is full. That's why we cannot able to insert the element. For that, what is the provision? Pranjal? What will be the provision for doing this? What is the solution?
Sir, we can remove one element and then we can insert.
Correct. So same thing we are doing here. What if it is not possible? What I will do? I will go for the pop. And for pop, first and foremost thing is stack should not be an empty stack. Okay, it should not be empty. Okay, so always whatever now for doing pop, what I'm doing, just I'm writing. See here for pop, I'm not writing any variable inside this function. Just I'm putting the function put pop. Previously for push we have to give the argument. In this case there is no need of providing the argument. So what I'm doing, top is equal to top minus 1. Okay, so I will extract the value one after another, right? So the top becomes, see, every time. Now first element which is there in the stack, which is first element inserted in the stack is 10, then 13, then 5, then 26, then 10. Who will be extracted first now? Who will be extracted first now? The last inserted element.
10.
Who is that element? Which is that element? Yes?
100.
Correct. 100 will be removed.
100.
Yes. And how to identify this 100? With the same procedure. Pop, top is equal to top minus 1. Current top is 4, will be extracted by minus 1, subtracted by minus 1. So likewise, we can go for the current top now becomes 26, not 100. Okay, now there is one space. We can now see this is for first pop. I can go for the second pop. I will remove the second element. Okay, likewise, I can go for the last element. Now, can I push 20 or 250? Can I push 20 250? Yes or no? Student, is that possible to push 250 by considering these two steps? Of course, yes. Okay. Hello. I'm getting.
Yes, sir.
Yes, sir.
Okay. Okay. So this much is sufficient for this discussion. Do you have any doubt in this? Yes. Array implement using linked list. The representation we'll discuss in next lecture. Okay. Up to this, there is any issue, any problem?
No, sir.
No, sir.
Correct. Okay. So just wait for 1 minute. I will give the attendance. I will give the link for the attendance. Just put your name and roll number. That's it. Okay. In chat window, there is attendance link. Please give your attendance, everyone.